let's think about how to calculate a problem for two-dimensional motion projectile. We have initial velocity VO and angle alpha with respect to horizontal starting from ground, for example. Now be very careful that the next moment, if we want to draw the trajectory, it's something like that. That is V final before impact. And you have to be very careful that the next moment that V does not have the same direction as VO. So you cannot, this alpha is instantaneous, it's only initial. A moment later that V changes direction, so alpha changes. So it's curved, it's not straight line. This is the peak point. So if we want to know what is the maximum height and what is the range around the x direction, how long does it take? That means t total. How do we solve this problem? Remember, x and y are independent. So x direction, we say. Remember that v of x at any time equals to v of x of initial. In our case, vx initial is VO cosine alpha. So, since x direction is a constant velocity, x direction's displacement r is that constant velocity times the time. So if we get the total time, we get the total range around the x direction. X direction is constant velocity. Y direction. Y direction is relatively simple because we start with a V of y initial. That equals to VO of sine theta. Should say alpha. And then there is a G involved, right? So, if we start from point A, we end at point A. AB have the same horizontal level. Therefore, from A to B, that gives us a total time, right? Because A is here, B is almost hit before the impact. Then we say delta Y, talk about Y direction, delta Y of AB equals to, the equation is V initial Y of T plus 1/2 of AY of T squared. Remember that equation? Since AB have the same horizontal level, then delta of Y is 0. V initial Y is VO sine alpha. And if our up is positive, then down will be negative for the G. So it's negative 1/2 of G of T squared. And if both sides divide by T, and this T cancels, this is 0. So 0 equals to VO sine of alpha minus 1/2 GT. So now we solve our T total. Our T total is twice VO of sine alpha divided by G. Again, we suspect that up is VO sine alpha G, down is VO sine alpha G. That's exactly true if you can trace back to chapter 2's problem. So, we solve the total time. If we want to get the range R, that is V initial x is VO of cosine alpha times T, that will be twice of VO sine alpha of G. That's very interesting. Let's take a look. That is twice of VO get squared, G is here, and sine alpha cosine alpha. Now, trigonometry, 2 sine alpha cosine alpha, that combination is sine 2 alpha. So your R is VO squared over G of sine 2 alpha. You know, sine 2 alpha has a max value equal to 1. So it looks like if you want to get R of max, you have to make your angle 45 degrees. then sine of 90 is 1. This is the case from ground to the ground. So if you want to maximize the range R, alpha has to be 45 degrees, no matter what is the rate of initial velocity. Now we solved range R and total time t. How do we solve V final? It should be very simple, right? Because our V final comes with a x component. Anytime Vx is Vx initial, we only need to solve V final of y. Well, chapter 2, we did that, didn't we? V final y equals to V initial y plus AY of t. As long as we plug in the t total, we should be able to find it because V initial y is known, which is that. AY is negative g, and t total is solved. We can solve V final y. So finally, our expression for the V final is V final x of I plus V final y of j. Let's look at this interesting graph. Do you remember from ground to ground, the total range R equals to VO squared over G sine of 2 alpha? This tells us that, look at this, if the initial angle is 15, sine twice of 15 is sine 30. But if that angle is 75, sine twice of 75 sine 50. Sine 30, sine 150 have the same value. Therefore, if the VO is the same, when we shoot initial angle 75 degrees or 15, it will end up the same x range of R. Because when alpha is 15, we get sine 30. When alpha is 75, we get sine 150. That comes out same value. So as long as this V initial is same when we shoot 75 degrees or 15 degrees, we hit the same spot. So you can actually use this example to think that 60 and 30 will hit, see 60 come here, 30 come here, we shoot at the same point. 45 will have the longest x distance because when alpha is 45, sine 40 twice of 45 is sine 90, that's 1. So the max value, R max, you can ever have is VO squared divided by G because when sine is equal to 1. And the next one, let's take a look. It's very interesting. If this is the gun and we shoot something, well, if there's no gravity in the magic world, the bullet will should go this way. But because there's a G, at any time, actually it falls. It falls this much. That's why it ends up a curve. Because think about this. Our y position, if this is y equal to 0 initially, at any time later, right? Final y minus initial y is delta y equals v initial y. V initial of y of t minus 1/2 gt squared. What is that? V initial yt, as a matter of fact, is going up. And minus 1 of gt squared, it's free fall, drop down. Combining of that, the x direction with a v initial x times t, we have, see, this is the v initial x times t makes. That is v initial yt makes. So that's why it is such a straight line. But that's that one. It's not going to follow that because we have a minus 1/2 gt term. So the general position, if we want to describe R, that actually should be v initial of x of t plus v initial y of t. That makes this straight line. And then minus 1/2 gt squared. That makes that drop. So it ends up on the curve. That is anytime position. Now, so if there's a problem asking for what should be the initial angle if we want to, the moment we shoot a gun and we release the target, and that is a very interesting problem. This is one of the homework problem. We can take a look. Before we do that, we can work on something relatively simple, but fundamentally is very important. We shoot something up with initial velocity angle alpha with respect to horizontal and h meters above the ground. And this time it's not from ground to ground, it's above the ground. So the trajectory, if we draw or something, it will be something like that. Be careful, V final is not 0, that is before impact. The question is, how high? That is Y max, maximum height. How long does it take? T total. And what is the X range again? So this is initial of position. So what is your R, which is X range? Right? So how do we solve this problem? Again, it's very similar. That initial, we have VO cosine alpha. Y, we have VO sine alpha. That is the XY component. We need to think about X and Y separate again. So X direction, constant velocity. So R equals to VO cosine alpha. This is constant velocity at X direction time to time. So if you give me 2 seconds, I tell you how far it moved around X-axis 2 seconds. If you give me T total, I tell you that's the total X before impact. Y direction. Let's talk about that. Well, it is, if we want to solve time, there are 2 equations related to time. Do you remember chapter 2? One is delta Y equals to V initial Y of T plus 1/2 of AY T squared. The other one is about T, right? V final Y equal to V initial Y plus AY T. Now the danger of using second one is actually V final Y is unknown. So we cannot solve it. The best way to solve the total time is always using this one. Why? Because, see, this is your initial. That is your final. If we only talk about Y, isn't that true? Initial is h meter above the ground. Y is on the ground. So isn't that delta Y in this case? If up is positive, you are Y meters down. So delta Y is minus, is negative h, because you drop down h meters. That equals to delta Y, change of Y. Initial Y is VO sine alpha is positive because shooting up. T plus 1/2 AY is negative G T squared. Look at that. This is a simple quadratic equation. You can always solve it. H is known, how many meters above the ground. Initial velocity angle known. G known, and you can solve T. T is total time because only after total time you drop capital H meters. So you start from here, you end up on the ground. You drop, which is negative because moving down, because we define up as positive. G is negative, down is negative. So it's always a good idea to use this one to solve the total time. Once we know the total time, we can find our V final, because V final equals to anytime the X will be the same. So that will be VO of cosine alpha of I. That is any times Vx. X direction velocity is constant. See, X direction velocity is constant. And the Y direction, okay, it is VO sine alpha t minus GT. That gives you the J direction. this part is v final y. So the final velocity has I turn and j turn. Now if we want to ask how high, well, what's y max, it's pretty simple. If you separate this, see that? This is already no h, and you just need to find this part. That's easy because this Vy equal to 0. We can go back to chapter 2. If initial velocity is known, you choose this as initial point, that's final point. We can easily solve this much. Let's name it. This is the y1. We can easily solve y1. How? Do you remember that? That is, we use this equation. Remember? We say v final square minus v initial square equal to 2a delta, let's say y. Finals right here, 0. Say v final y 0. We'll apply to y direction. Initial VO is initial y is a VO sine of alpha s squared equals to 2. A is negative g because it's the y direction, right? Your delta y, since this is initial, this is final, that's y1 can be solved. Negative, negative cancel. So y1 is VO sine alpha squared divided by 2g. That gives you y1. y1 plus capital H give you the maximum height. So this is a very, very typical case that we start from somewhere above the ground and we shoot a projectile with initial velocity and angle, and we ask for how long does it take to hit the ground, how far it moves around the x direction, what's the maximum height, and so far so forth.